Well, this is the match the column type question in which in list 1 we have been given position vector as a function of time, and in the list 2 different physical quantities are given to us, that is linear momentum of the particle, angular momentum about the origin, kinetic energy, potential energy and total energy of the particle. So we have to talk about corresponding to each expression for position vector as a function of time in the list 1, what are the quantities in the list 2 which are going to be conserved. And we have been given that in each case the force acting on the particle is either 0 or the force is conservative. So it's really a good news because there will be no loss of mechanical energy. So one thing we can say that the total energy is going to be conserved in all the expressions for this position vector as a function of time. Anyways, let's check each expression for position vector as a function of time, and let's see what are the quantities in the list 2 which are going to be conserved. So we will start with the first expression first, that is position vector as a function of time is alpha t I cap plus beta t j cap. So now if we differentiate it with respect to time, we are going to get velocity vector and it is going to be alpha I cap plus beta j cap. If we again differentiate it, we get acceleration vector, and as you can see that alpha and beta are constant, so its derivative is going to become 0. That means acceleration is 0. If acceleration is 0, force is going to be 0, and if force is 0, then definitely linear momentum will be conserved. Now if the force is 0, definitely the torque is going to be 0. If torque is 0, then we can say that angular momentum is also conserved. Now let's talk about kinetic energy, whether it is conserved or not. You can see that the velocity is constant and therefore speed is constant, and therefore kinetic energy is constant or it is conserved. So kinetic energy is also conserved in this case, and we already know that total mechanical energy is conserved, therefore its potential energy is also going to be conserved, and therefore this P in the list 1 is going to match with all the options in the list 2, that is 1, 2, 3, 4 and 5. Now let's look for the next expression of position vector as a function of time. The second expression for position vector is alpha cos omega t I cap plus beta sine omega t j cap. So if we differentiate it, we are going to get velocity vector as minus alpha omega sine omega t I cap plus beta omega cos omega t j cap. And if we again differentiate it, we are going to get acceleration vector which will be equal to minus of alpha omega square cos omega t I cap minus beta omega square sine omega t j cap. So this is going to be acceleration vector, and if you want to find out force vector, then it is going to be equal to, we just have to multiply this acceleration with mass, and it will become minus of m omega square in bracket we have alpha cos omega t I cap plus beta sine omega t j cap. So as you can see that the external force is non-zero, and since we have a non-zero external force, we cannot conserve linear momentum at least. Now let's talk about whether we can conserve angular momentum or not. For that we have to see whether the torque due to this external force is 0 or non-zero, because the presence of external force doesn't mean that the torque should also be present. It is also possible that the torque due to that force may be 0. So let's check if the torque due to this force is 0 or not. So one way of finding the torque vector is going to be equal to r vector cross f vector. We already know position vector and the force vector, you just have to take its cross product. And if you don't want to go with this method, we have an alternate approach of doing it. It's very easy. Let's imagine that this is the coordinate axis and this is the point whose position vector and the force acting on it is known to us. So the position vector, that means the x coordinate is alpha omega t, that means this distance is alpha cos of omega t, and the y coordinate is beta sine omega t, that means this distance is beta sine omega t. Now what about the force? The x component and y component of the force both are negative. So you can see that the x component is going to be alpha cos omega t times m omega square in the left direction. So it is in the left direction m omega square alpha cos omega t. And in the negative y direction, it is again m omega square beta sine omega t. So in the negative y direction, it will be m omega square beta sine omega t. Now you can see that about the origin O, one of the force is providing a torque in the clockwise direction and the other force is providing it in the anti-clockwise direction. So we just have to check whether the net torque is going to be 0 or not. For that, we just have to multiply the force with its perpendicular distance. That means if we multiply this force, that is m omega square beta sine omega t, which is providing a clockwise torque, so this force must be multiplied by alpha cos omega t. That is its lever arm, that is it is the perpendicular distance of this force from the origin, and we see whether it is going to be equal to the anti-clockwise torque, which is going to be equal to m omega square alpha cos omega t multiplied by its lever arm is beta sine omega t. So we will find that the product of these two quantities are going to be equal. That means the clockwise torque will be equal to the anti-clockwise torque, and therefore we get a situation that net torque about the origin is 0. And since net torque about the origin is 0, therefore we can say that this angular momentum is going to be conserved. Now what about kinetic energy, potential energy and total energy? We know that already total energy is conserved in all the cases. So let's talk about the kinetic energy. For kinetic energy, we just have to focus on the magnitude of the speed. So magnitude of the speed is under root of x component of the velocity square plus y component of the velocity square. When you do it, then you will find that the time is not going to get eliminated, and therefore speed is going to vary with time, and therefore kinetic energy is not going to be conserved. So if kinetic energy is not conserved, total energy is conserved, therefore potential energy should also change. So as the kinetic energy increases, potential energy will decrease. Therefore for this Q, the correct match is going to be 2 and 5. So now let's look for the next expression for position vector as a function of time and see what are the quantities that are conserved in the list 2. Now the next expression is position vector equal to alpha times cos omega t I cap plus sine omega t j cap. And when we differentiate it, we are going to get velocity vector as alpha omega minus sine omega t I cap plus cos omega t j cap. And when we again differentiate it, we are going to get acceleration vector as minus alpha omega square cos omega t I cap plus sine omega t j cap. I have taken the minus sign outside this bracket, so it is how it is going to look like. And the force vector will be equal to mass times acceleration, so it is minus of m omega square alpha cos of omega t I cap plus sine of omega t j cap. So you can see that external force is non-zero, and therefore this linear momentum is definitely not going to be conserved. But let's talk about the angular momentum, and for that we know that we have to find out the torque about the origin. And for that, let's imagine that this is the coordinate axis and this is the particle that you have. And what are the force experienced by this particle? The x component will be in the left direction and the magnitude of the force is m omega square alpha cos of omega t, and the y component of the force will be in the downward direction and the magnitude is m omega square alpha sine of omega t. And what is the x coordinate of this particle? It is going to be alpha cos omega t. So this distance is alpha cos omega t, and the y coordinate of this particle is alpha sine omega t. So it is alpha sine omega t. Now you can see that because of this force m omega square alpha sine omega t, it is going to have a clockwise torque, and the clockwise torque will be the multiplication of these two quantities. And because of this force m omega square alpha cos omega t, there will be anti-clockwise torque, and the anti-clockwise torque, its magnitude is going to be the multiplication of these two quantity. Now you see that the clockwise torque is going to be equal to the anti-clockwise torque, and that is why we can say that the net torque is going to be equal to 0. and since the net torque is equal to 0, therefore we can conserve angular momentum. Now let's talk about kinetic energy, potential energy and total energy. For total energy, we already know that it is already conserved. So let's talk about kinetic energy. For that, we have to talk about the magnitude of the velocity, and the magnitude of the velocity, if you try to find out, it's going to be equal to alpha square omega square, because this term, this bracket is a unit vector, and you can see that this speed is independent of time, and therefore kinetic energy is going to be conserved. And since total energy and kinetic energies are conserved, therefore potential energy is also going to be conserved, and therefore the correct match to the option R is going to be 2, 3, 4 and 5 in the list 2. Let's now talk about the last expression for this position vector. So the last expression for position vector is alpha t I cap plus beta by 2 t square j cap. If we differentiate it, we get velocity vector as alpha I cap plus beta t j cap, and again differentiating it, we get acceleration vector as beta j cap, and the force vector is going to be mass times beta j cap. So you can see that the force vector is non-zero, and this is why we cannot conserve linear momentum. Let's talk about the angular momentum. For that, we have to see whether the torque vector is 0 or non-zero. Torque vector is r vector cross f vector. We know that this force vector is a constant vector, and this position vector is changing with respect to time. Therefore, the product of position vector with force vector is going to change with time, and therefore this torque vector is variable. And since this torque vector is variable, definitely we can say that torque vector is non-zero, and therefore we cannot conserve angular momentum as well. Now let's talk about the energies. We already know that we can conserve total energy of the system. So now let's talk about the kinetic energy and potential energy. For kinetic energy, let's look at the speed. So if you look at the speed, the x component of the velocity is constant, but the y component is variable, and therefore the speed is going to be variable, and therefore kinetic energy cannot be conserved. And since total energy is constant, kinetic energy is variable, potential energy should also be variable, so we cannot conserve potential energy as well. So the only thing that we can conserve is the total energy. So the correct match with option C in the list 1 is going to be with the 5th point in the list 2. So you can see that in this problem of match the column type, which looks very difficult, however this problem was very easy, although little bit lengthy, but if you know the standard results, for example in case of Q and in case of R, in case of Q it is an elliptical motion and in case of R it's a circular motion, probably you would be able to do it directly, but still you have to make calculations in order to be sure about your answers.